Hi, I'm Stefania Chaplin from Sonotype, and I'm going to be talking about embracing security, a changing DevOps landscape. So I've been talking to a couple of you at the event, and security does seem to be a thing that quite a lot of people want to get involved with, so I can see from the audience. So yeah, you've come to the right place. So to start off with, who am I? So I went to University of Manchester in England, which is actually where the first ever computer was invented, where I studied Java, and I did about 4 or 5 years of it. Then I worked in a Polish startup called Vacancy Soft, where I did a bit of Python, and now I work at Sonotype. And the reason I have that image, because I was trying to think how I could sum it up, well, apart from I travel quite a lot, being a solutions engineer, every call I have, I'm just thrown with new languages and technologies. It's like, oh yeah, Kotlin, Bamboo, AWS, Harbor, GitLab, etc. And I'm like, okay, let me just think about how that fits into everything. So it's quite full on. So, Equifax. Some of you may know about Equifax. So they had, they're a personal records company. So say if you want to take out a loan, they're going to look at all of your personal information, credit history, etc. And they are potentially the biggest hack ever. So they had approximately 150 million personal records. So before this talk, I had a quick Google, population of Sweden. It's about 10 million. So imagine 15 Swedens. Or another way, like every single person in France and every single person in Germany put together. That's how many people got hacked. So what happened to them? So March 7th, Apache Struts found a problem in one of their Struts components. So it was Struts 2 core 2512. And they published a CVE. So that kind of almost the good guys, because they had a problem, here's the fix straight away. But then what happened? 3 days later, Equifax was hacked. So they were breached through the Struts 2 vulnerability. So they've literally got about three days. The problem was they didn't actually realize until July 29th. So that gives the hackers this huge window, which you found throughout, initially it was just a little who am I? And then once they'd done a bit of exploring, found out enough things, then they started the large-scale exploit and started mining all of this critical personal information. So like I said, probe first, then exploit. What happened to Equifax? They had this little green patch here. That's all they had all the time they had to fix their vulnerability. And if you think a company like Equifax, it's pretty big, so they've got, maybe even thousands of applications that they have to patch. I don't know if anyone here has ever been asked, are we using Struts 1 or Struts 2 or a specific component in your, estate? It's not a very nice question to hear or to have to find out. I speak from previous developer experience. It's not fun. So how can you do this without automation? If you're relying on manual processes, it's not really going to go well if you have, 3 days to fix it. So what happened to Equifax? They then went through crisis management. So this was just before GDPR. Obviously, GDPR, they would have had to announce within, I think it's 24 or 48 hours. But what happened? So the CEO, CISO, and CTO all took early retirement. They lost about 5 billion off their market capitalization. It was about 30%. And this hack so far has cost them hundreds of millions to fix, not only in fixing the tech, but also, the PR, etc. And then actually, so Equifax went through this whole process of trying to, what can we do, how can we fix it? They actually decided to go with us. So there's a great press release. I can tell you about it afterwards. Anyway, so at Sonotype, we do something called the State of the Software Supply Chain. And we do it every year for about the last 4 years. So what is the software supply chain? So it's kind of similar to the traditional manufacturing supply chain. So you have your suppliers. So in this part, these are the open source projects. So these are, for example, your Apaches, and they're, creating these open source components. They're supplying these components. So what happens? Then you have your warehouses. So this is where you're storing these open source components. So this would be your local repositories, such as Nexus, Artifactory, etc. Then you have manufacturers. So this is the software development team. Because if you think about it, software developers, we aren't programming from, the beginning to the end anymore. We're, smart, innovative. We don't want to, we don't want to reinvent the wheel. So we are using this open source. So what do you find? We're just assembling. So we're kind of taking all these open source, patching it together, and then boom, feature, amazing. And what you end up with, your finished goods, those are your software applications. So we had a look at the average number of new open source projects coming to market per day. And we looked at NPM, Java, NuGet, and PyPy. And if you look at the difference, so this number here, this is 2011, it's about 150 per day, which then goes up to about 12,000 in 2017. So what you're seeing about that, that's about 1,100 new projects every day. And about 10,000 new versions every single day, which can vary. You've got some projects that are very agile, you know, every month, every week, every day, and other ones that haven't released. Oh, you're on the latest version. Oh, wow, it's 14 years old. So obviously, this can vary massively. And you're going to start to see, this is a common thing in my presentation, this kind of line. So if we look at the next slide, so this is the number of downloads from Maven Central. I'm going to take quite a lot of you program in Java. This is JFocus, obviously. So at Sonatype, we own Maven Central. So if you've ever downloaded any Java open source, it's probably come from there. And we had a look at the numbers. So if you look back to 2008, obviously a very long time ago, there were 1 billion downloads per year. And then, obviously, you can see that number creeping up. You know, when I started, this was only 52. I was on that slide, and obviously, we keep getting the slides updated. And you can see this huge exponential growth. And if you think about it, it's not like the number of developers is growing exponentially. It's not like we had 1 million developers 10 years ago, and now we have 146 million. What this is showing is a change in developer behavior. Because we're using the open source. It makes our jobs easier. It works. You know, why not? And this isn't just Java, this is JavaScript as well. So this is from Laurie Voss, who's actually the CTO of NPM. So if you're using any JavaScript, you're probably getting it from NPM. And he has a similar trend. So if you look at 2013 to 2018, NPM users downloaded 5 billion packages in the last 7 days. On this day, 4 years ago, that figure was 50 million. So that's 10,000% growth. That's something else you'll notice. So I do a little bit of Java, a bit of JavaScript, and if I'm ever coding in JavaScript, transitive dependencies, it's a little bit messy. So what we're finding, and you know, as part of my role, I travel, you know, across Europe, but we're global, big companies, little companies, all of the different industries, and overall, 80 to 90% of modern applications consist of assembled components, and that's across all the languages. To be fair, JavaScript is normally even a little bit higher, because like I said, developers, we just want to get the job done. Oh yeah, should I write, you know, a PDF scraper? Oh no, I've just found one on Google. Let's just use that. Okay. And this isn't just across components. So this was taken from the Docker convention, I think, last year. And you can see this is obviously maybe a logarithmic scale. You've got 1 million in 2014, up to 1 billion in 2015. And then it grows with this upward trend. So what you're seeing as well, 80 to 90% of modern operations consist of assembled containers. So you're seeing the rise of Docker, AWS, OpenShift, etc. However, not all parts are created equal. So we had a look within Maven Central, and we looked at 122,000 components with known vulnerabilities. So that means there's a CVE, you know, there's an RCE, XSS, denial of service. There's a problem with it, and it's published. And of those vulnerabilities, nearly 20,000 fixed the vulnerability, which is about 15.8, so just under 1 in 6. So that's great, okay, 1 in 6 are fixing it, 5 and 6 aren't, but they're taking their time. So the average was 233 days mean time to remediation and 119 median. So if you think about the Equifax example, they had 3 days, and then the average is, you know, months. So like I said, Apache Struts, they're almost the good guys in the situation. They realized they had a problem. They patched the vulnerability on the same day, 0 days mean time to remediation. So there's obviously a disconnect because you've got your suppliers. They've realized they've had a problem. It's almost like in car manufacturing, there's a product recall. But then the users of these components, say Equifax, are they not, acknowledging these vulnerabilities? Do they not realize these things need to be fixed? So we had a look at 7,500 organizations, and on average, it's about 170,000 components, of which 3,500 unique. So that's, a little bit of version dispersion in there, but, whatever. And of that, there were 18,870 vulnerabilities. So 11% had known vulnerabilities. The issue is Equifax was not alone. So let's have a look at what else happened in March. So as I said, there was a vulnerability. All of a sudden, March the 8th, the next day, in America, the NSA reveals Pentagon servers scanned by nation states for vulnerable Struts instances. So that's, 24 hours. Then, March the 9th, 2 days later, Cisco observes a high number of exploitation events. All of a sudden, then, things kick off. March the 10th, you've got Equifax, you've got the Canada Revenue Agency, you've got Canada Statistics, you've got Japan, GMO Payment Gateway, and that was 3 days. So how can you fix these kind of things without automation? Then we have the rest of the story. So this is all of the same vulnerability, the same component. So March 13th, the Japanese post. April 13th, my birthday, India post. December 17th, there was a lot of Monero crypto mining. March 18th, India's AAD-HAAR, that's their biometric ID system. And that's the issue as well. I do a lot of reading about biometrics. And that's the thing. Once your fingerprint or your retina gets hacked, how can you get a new one? It's not like, oh, I lost my bank card, give me a new one. It's like, oh, my fingerprints have been hacked. Like, it's not quite as easy. And then we have today. So as I said, Sonatype, we own Maven Central, so we can see, what's being downloaded. And 8,780 companies continue to download vulnerable version of Struts, the same version that Equifax got, and all these others got hacked by. And in America, that's 57% of the Fortune 100. So what are people doing about it? 6 in 10 have open source policies. That's great. So we do something, I think it's the DevOps community survey. So we ask, different industries, different professions, kind of their opinions, if they've been hacked, what are they thinking, what are their priorities, and people are starting to have policies. Unfortunately, they're not really working. So when we ran these numbers, we actually had to do a retest because you had 2014, 6.2% of every single download from Java was vulnerable. Then 6.1, 5.5, okay, few, it's shrinking, it's about 1 in 18. All of a sudden, 2017, that's 12.1%. So that's about 1 in 8 of every single Java components downloaded has a known vulnerability. So if you think of the chart, of the 146 billion, that's about 1 in 8. So that's like, 17, 18 billion downloads every year are vulnerable. And this isn't just, oh, it didn't click. This isn't just in Java. This is in JavaScript as well. So we have in quick audit stats, so this is from a talk that NPM did, and they said of 4 million scans per week using NPM audit, 51% had vulnerabilities, 37% were high, so this means a CVSS of maybe 7, 8, or 9. And then 11% of all the scans had a critical vulnerability. So 1 in 10 had a CVSS 10. And what that means, common vulnerability scoring system, some of you may have heard of it, it's a scale from 0 to 10. It's to do with ease of exploitability. So, your 1s or 2s, you've got to be someone who knows what they're doing and have, access and credentials and all this. A 10 is, you can almost get a pre-baked script off the internet and just put it in somewhere and boom, you're in. So there was a university in America, they also looked at JavaScript, and they had a look at front-end websites, and they looked at a couple of thousand. And what they found within Handlebars, so a popular framework, 87% of Handlebars inclusions were vulnerable. jQuery, 37%. So there are over 72,000 versions of jQuery. So how do you know which one you're using, or even if it's safe? And then similar, Angular, 40% of inclusions were vulnerable. So if we kind of look at the timeline of what's happened, so this is some more data from our survey. And in 2014, we asked, anonymously obviously, do you suspect or have you verified that you've had a breach within open source components? And back then, 14%, 2014, and that's when Heartbleed happened. The thing I talk about CVSS, 0 to 10, Heartbleed was only a 5. So anything over a 5 is kind of even worse. Then you have 2017, 20%. So 1 in 5 either suspect or they have been hacked. In 2018, that number's gone up to 31%. So nearly 1 in 3 of all of the kind of companies that we surveyed, and it was a very big survey, like tens of thousands of results, they suspect or they have actually been hacked. So let's have a look at kind of the timeline. So this is, I call it a shifting battlefront of attacks. Hackers inject malicious code into supply chains. The text's going to be quite small, so those at the back, don't worry, I'll read it out. So we're going from March 2016 to August 2018. So what happened in March 2016? We had LeftPad. So that was when a little, I think it was about 12 lines of code got deleted from NPM, and boom, like 70,000 builds failed globally, including some within Google and Facebook. And all that had happened was one of the contributors had a bit of an argument with NPM. It was a bit like a David and Goliath story. So he was like, fine, I'm out. Just deleted all of his code, including this LeftPad. And the implications, because if everyone's pulling from NPM, and then something goes, build will fail. It's like, why has that happened? Which I stress, why people need a local repository, because then you're not affected by this. So that was March 16. Then in July 17, NPM credentials used by publishers of 79,000 packages were published online or easily compromised by dictionary attacks. So this is the problem. If you're having credentials issues, there are obviously a lot of people I like to think are on the good side, but you do have some bad players that, oh, I've got some credentials. Actually, this is a funny story. I woke up this morning with an email saying my Steam has just been accessed from Moldova, and I was like, oh, I use my Steam for video games, and someone's hacked me, so I need to remember to change that password. But that's what I mean. If people are accessing my password for my video game site, what happens with NPM, where you can actually do something more malicious than, buy video games? So then, number 3, there was a typo squat. And the issue with typo squats, so this is more of an issue, say, in Java, Python, Ruby, the languages that don't have like Java, GAV, group artifact version. And part of the reason we have group artifact is to prevent typo squatting, because it's a lot harder to typo squat if you've got a group and an artifact. If, say, for example, I know Python recently, there was a colorama, they had the American spelling and the English spelling, and all of a sudden there was kind of malicious code in there. So we had a typo squat where 40 intentionally malicious packages were harvested credentials used to publish to the NPM repository itself. Then number 4, so this is all in July 2017. Docker 123.321 images were created on Docker Hub. And then in Jan 18, it was accused of poisoning a crypto mining, a Kubernetes honeypots, and then it was in a crypto mining botnet. So you're starting to see a trend, and what you're seeing as well is these kind of things are accelerating, and it's language agnostic. It's not specifically Java, but it's kind of happening everywhere. As I said, 5, typo squats. So there were about 10 packages that got typo squatted in Python. Number 6, so I don't know if any of you have read this article. It's on Medium. It's actually, I think it was either their top 1 or top 2 articles. It was literally something titled like, I've harvested all your credit card, I hacked you and harvested all your credit card details, and this is how. And it's this fictitious article, but it's absolutely amazing because they're literally describing how they would hack you. It's like, oh, you say, oh, I've got pen testers. I'm like, do your pen testers work from 7 p.m. to 7 a.m.? And it's a story about how someone injected some code into a little library about coloring font, but then got that as a transitive dependency of other libraries, and all of a sudden, they were able to, mine loads of Bitcoins. Obviously, 100% fictitious, but it almost prints a blueprint of how easy it is to hack if you have, bad intentions. Number 7, so this is another one. This was also a Monero crypto miner. You're going to start noticing a lot of trends. This was NPM credentials. So this was conventional changelog ecosystems had credentials compromised. Number 8, so Go bind data. So this was a bit of an interesting one because someone was like, right, I'm out. Let me just delete my account. And then someone's like, oh, that account's free. Let me just save the same name and just, I think it was a good player. They're like, oh, okay, let me let me just, reinstall everything so none of the builds will fail. We want to prevent NPM left pad. But actually, all of a sudden, you can start ingesting kind of malicious codes. So that's why you have to call into the question that packages and sources are canonical and immutable. So like I said, Maven Central, we're quite good at that. If someone, we don't really let people delete things because for that reason, builds will fail, and then other people might come in with malicious intentions. Number 9, backdoored NPM. So this was to do with unauthorized publishing of a mail parser. As I said, backdoor. Number 10, backdoor PyPy. This was happening about May 18. So you're seeing as well the trend between, March 16, that was the first, incident. July 17 to May 18. All of a sudden, you're seeing attacks almost every month. It's been pretty intense. And then 11, so this was a Homebrew breach. I'm going to come to this a bit later. And what happened is someone left there, someone managed to get access through GitHub API tokens that were just, just lying around on GitHub. So let's look at some real-life Java examples. Bouncy Castle, cryptographic library. Some of you may know it. The ironic thing about this one is people that are, using this library are interested in cryptography. They like security. They want to be secure. However, in 2007, there was a CVE with a base score 10, 10.0. 10.0 is actually very hard to get. When I or my colleagues find them, we tend to do it like, oh, I found a perfect 10. Let's put it like in a little database, save it for later. And so 2007, it was, there was a problem, published, vulnerability, etc. In 2016, so 9 years later, 23 million downloads of Bouncy Castle, of which 11 million, so nearly half, had this vulnerability. So what we're saying basically is almost 50% of downloads of Bouncy Castle have this vulnerability. I like to think that under 50% of developers in general aren't intentionally trying to backdoor for later. So what this is kind of saying is, are developers getting the information? Do they know what versions they're using? Do they know if there's a safe version? Do they know why it's vulnerable, if it's vulnerable? Have they looked at transitive dependencies? I know from personal experience, when I was a Python developer, if I was using a library, okay, fair enough, I was at a startup in Fairly Junior, do the Google search, have a look, maybe Google around a bit, and then move on. Because if I spent much longer, I may as well have written the open source by myself. Did I look at the transitive dependencies? I'd like to say I did, but so this is the thing. Developers, we have requirements. We're trying to get features out. Do we have time to research every single open source component we use? Or even worse, do we have time to ask someone else to research it and then wait 3 weeks for a simple yes or no? So commons collection, this is quite an interesting one because so far we've been talking a lot about Bitcoin, Monero crypto miners, well, I've been talking about credit cards and games, but anyway, more finance stuff. So what happened with commons collection, as you can vaguely see from the back, so actually in Hollywood, Presbyterian Hospital got hacked. So all of a sudden, it's going from, laptops and money, etc., to all of a sudden, if a hospital gets hacked, and then their systems were totally shut down, what happens then? Like, people that are going there for emergency surgery have to suddenly be transferred to other hospitals. If people are locked out of system, it suddenly becomes more of a life or death thing. And like I mentioned about kind of IoT, one of my colleagues, his dad has a pacemaker. So what happens when people put pacemakers in? Oh, it has Wi-Fi, because then it will tell the hospital if you're sick. Great, but what happens if someone intentionally hacks the Wi-Fi and turns it off? So this was the thing, and this is, as I said, kind of commons collection. There were approximately 24 million downloads in 2016, of which 80 million, so 78% of all of the downloads of common collection were vulnerable. And the ironic thing about this library, there's about 35 versions, only 7 are vulnerable. They're quite high vulnerabilities. But anyway, it just happens, 20% of the versions account for nearly 80% of the downloads. And I think a lot of that is to do with transitive dependencies. So some of you may have heard in November about the latest Struts outbreak. So I think it says here, on the 5th of November, Apache Struts said there's a new vulnerability, it's with commons file upload, so it's with a transitive dependency. But if you have a look at the NVD, so this is CVE 2016. So this isn't a new vulnerability, it's just Apache with then looking at their transitive dependencies. And if you look, the published date, so 25th of October, 2016. So this is the thing. It's great. I know that a lot of people will look at the, top-level dependencies. But when you're going into transitive, how are you managing that? Are people managing that? Is it possible to manually manage that? Or do you have to have a huge team to do that? I know, because at Sonatype, we literally have a huge team doing it. So, coming back to this one, Homebrew. It may have seemed familiar to a couple of you, particularly brew install ... I have a Mac. It's literally my savior. It makes life so much easier. I never have to leave, the terminal. However, in August 2018, an operations engineer at a company just was perusing around, and he gained commit access to Homebrew in under 30 minutes through an exposed GitHub API token. So he had no malicious intent. He was just, wandering around. But Homebrew is downloaded 500,000 times per month. So imagine if he did have a malicious intent. If it took him half an hour, then what does this mean moving forward? So this was a non-malicious attack. What happens when you have a malicious? So we had EventStream. So this was an NPM package. This was a few months ago. And this is a very, very, very popular library. And what happened was there was EventStream, and then there was a transitive dependency FlapStream, and that's where the issue was. And this is taken straight from GitHub, because what happened? A malicious player emailed one of the owners, and then he emailed me and said he wanted to maintain the module, so I gave it to him. I don't get anything from maintaining this module, and I don't even use it anymore and haven't for years. So this is the thing, behind a lot of these things, there are humans involved. You have bad ones, you have good ones, you have lazy ones. But what's going to happen if you have these actors that are going in, that, the latest forefront is application security, because everyone has their WAFs, their perimeters, their firewalls, so that's not necessarily easy for the hackers. But all of a sudden, email someone on GitHub, oh yeah, hey, can I maintain, la 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 la, and just inject, I don't know, a few lines of code into a transitive dependency. All of a sudden, 2 million downloads a week over 2.5 months before being discovered. So, back to Java. So this is looking at struts. So, going to notice the trend. This was the struts 2 core. So this is when Equifax was breached, March 17. July 17, the breach was discovered. And you're kind of like, okay, 100,080, not much change. Breach discovered, breach disclosed. Now it's obviously a big deal. People are finding out. Still, not much change. So 12 months since Equifax breach, it's not like there was a sudden, where's my pointer? It's almost statistical noise. It's maybe a drop of, maybe 10 or 20,000, 10%. So you can't attribute that to the press releases. People necessarily aren't getting the information, aren't paying attention, maybe they don't care. And this isn't just struts. So this is, you may be sitting here thinking, it's fine, we don't use struts. Maybe you use Spring. So this is the download statistics for components affected in the Spring Break vulnerability. So that was from 2017. And you're seeing the same thing. So this is kind of before vulnerability disclosed. And then it stays about the same. Okay, it drops a bit in December. I'm going to say that because of Christmas. But what you're seeing is these huge hacks, people, losing jobs, losing money, getting in trouble. It's not affecting behavior. And this is a big problem because the average day before a vulnerability is exploited, your window has dropped massively. So 2006, you had about 45 days before you exploited. So maybe you find out about your vulnerability, and you're like, okay, let's find out where it is. Okay, how do we remediate? You've got a bit of time to process this. All of a sudden now, Equifax, you have 3 days. So how do you do that with a manual process? You've got to start automating. You at least need to know what components you're using, what your transitive dependencies. So that way, if there is a new struts or Spring or Commons collection, you at least know if you're using it and then can act quickly based on that. So if we look at something Gene Kim said, so he's almost the father of DevOps. So he said, emphasize performance of the entire system and never pass a defect downstream. So what he's talking about is shifting left, because it's so much easier. Speaking as I say, an ex-developer, I would much rather be in my IDE, download a component, oh wait, that one's bad, okay, let me upgrade or choose the next version, rather than do my software, push it, move on to my next project, maybe another project, and then about 2 months' time, pen testing, you're like, oh, by the way, cross-site scripting within one of your components. I'm like, what was that program? And I have to take about 2 hours just to acknowledge what I'm doing. And that's the thing, context switching sucks. So we want to shift left, don't pass defects downstream, because you want to, if you're passing non-vulnerable stuff, it's probably going to be a lot easier in the long run, especially since, on average, developers outnumber application security about 100 to 1. And this is quite a broad figure. I've been in companies where it tends to be maybe 300 to 1. So why don't we leverage that resource? Because I know, well, ex-developer, I can't speak for everyone in the room, but I know, I want to do the right thing. I'd be much happier if I'm confident, I'm using safe software, I move on to the next project, rather than have that feeling like, oh, I didn't quite check the third level transitive dependency of that JavaScript library, etc. So let's have a look at the software development lifecycle. So you have your developers. They'll pull from version control, pull from the local repository, and pull from the public repository, so Maven Central. Once developers finished building, goes back to version control, into the CI server. CI server uses the same open source components from local repository. Once build is done, back into the repository, deployment, development, QA, testing, and production. So we call the left side CI, the right side CD. Hopefully this should seem familiar. This is fairly, DevOps-y. Not everyone's going to be the whole way here. Some people may just be experimenting with CI. Some may have the whole pipe. But this is a generally accepted model. So where do you find security? So a lot of people I've spoken to, they have, normally a team. So say if you want to download a component, you're going to have a little stop. You're like, I would like to download this component. Some companies, they don't even have internet access. They literally have to make a request for a component. Someone manually researches it, the vulnerabilities, the licensing, etc. And that can take weeks to approve, at which point the developer's so frustrated that they're like, I could have written it myself, or one of my colleagues, this was a long time ago, he wasn't allowed Spotify, so he just renamed Spotify to his name.exe, and that's how he got it in. And that's the thing, if developers are waiting weeks to improve, it's stifling innovation and creativity. So this isn't a good process. The other problem, a lot of people have pen testers. Pen testers are great. But if you rely solely on penetration testing, it's too late. Because if you think about it, that's right at the end. And what you're normally finding with projects, okay, here's our project, here's our deadline, we're right here. Oh, let's just quickly do some pen testing. Oh, they've come back bad, we're already over time, over budget. Okay, someone just signs off and it's in production. Which obviously isn't ideal if you look at all of the things that have happened kind of during my presentation. So what can you do? So I work with Sonatype. We have a thing called Nexus Lifecycle. And what we want to do, we want to shift left. So early feedback. Wouldn't it be great, as I said, as a developer, having like a little plugin in your IDE to see what components you're using, what's vulnerable, what's safe, why it's vulnerable? Because it's great being told, change that, but you kind of want to know why. Change that because this method is bad and you've got an RCE. Great, okay, now I understand, I'm on board, let me change that. We want to block bad stuff. So similar to, what's happening traditionally in terms of, having approval process, but instead of a manual, someone with a list of licenses or, encyclopedia of vulnerabilities, why don't we automate that? Why don't we have, say, Boolean logic? If it's a CVSS 10, let's block it. If it's a CVSS 2, okay, we'll let it in, but at least tell me it's a CVSS 2. Policy enforcement, so similar. If you're pushing builds through, CVSS 10, block those builds. CVSS 2, or weak copyleft license, okay, let's let it in, maybe make the builds unstable. And then what you end up with is all trusted, all known components in your repository, because wouldn't it be great to just know what's in your repository, what you're downloading, all the transitives, everything? And then also, just in case, just before you deploy, because this is the thing, imagine if you did your build on March the 6th, but you didn't deploy until March the 8th. March the 7th, that was when the Equifax thing happened. And these vulnerabilities come out every day. So you need to have these multiple policy checks in order to, keep on top of kind of what's going through. And then also, that's great. Okay, we're building, but what about legacy applications? What about things that are not necessarily in active development? Maybe no one's looked at in a while. Wouldn't it be great to know? Okay, March the 7th. Oh, that application that you put in production 6 months ago. Oh yeah, that had struts too. Do you want to fix it? Here's how. Wouldn't that be great? So as I said, Nexus Lifecycle integrates with the IDE, integrates with CI, repository, and deployment. We can even, look at commit status updates. And then these are some of the ways how. So taking it back a little bit. So this was Edwards Deming. So he was very, very popular in Japan because he did he came after the World War. He spent a lot of time with Japan car manufacturing. And then he came, and he was seen as a, savior. And then he did a lot of work looking at and comparing the way that Japan made cars and the way that America made cars. And what he found was in Japan, they had, good quality parts. They had a standardized process. They didn't use defective parts, and it was just very streamlined. And obviously, 30, 40 years later, this seems like common sense. But back then, it was revolutionary, because what you found in America, everyone was doing their own thing. If a part was broken, they would just fix it in rather than having good quality parts at the beginning. So he said, you cannot inspect quality into a product. It's a bit like crashing your car into the wall and checking if the brakes work. It's like, why don't we build it with good quality parts? Why don't we put in good brakes to begin with? What we say is if you reduce downstream defects, so having checks at CI, having checks in warehouses, having checks everywhere, what we saw was a 48% improvement in application quality when you had unmanaged versus managed supply chains. So what that means in terms of quality, so that's security, licensing, everything in terms of architecture, the whole, looking at everything. And the rewards are impressive. So I can't quite say who, but we looked at some of our customers. And overall, with one investment bank, there was a 90% improvement in time to deploy. So they reduced their time to deployment from 25 days to 2.5 days. I still ask what they're doing for 2.5 days, but that's a different story. Then we had credit card company. They saved 34,000 hours in 90 days. So what that was from, the old process, I would like a component. Okay, let me research it, let me have a look, la la la, la la la, this person's here, okay, how long will you be? And then here you go. All of a sudden, by automating, by instead of looking at individual components, the whitelist, blacklist traditional approach, why don't we blacklist on CVSS numbers or licenses instead of, oh yeah, commons collection is bad. Commons collection 321 is bad, 322 is actually okay. And then the light side, this was another investment bank. They had a 48% increase in application quality. So, final slide. 3 takeaways for everyone. So, number 1, have a software bill of materials for each application so you know what open source you are using. It sounds so simple, but if you think about, okay, great, yeah, I've got my POM, but are you looking at the transitives of those? Are you looking at the next level or the next level? Or are you looking, I recently did a little, over Christmas, I was working over Christmas, and I did, using Maven dependency tree, I combined that with a JavaScript framework. So I literally started mapping a dependency tree, and there's this intentional application called WebGo, and then I printed that out, and because I think it involved Selenium, which is a testing framework, all of a sudden I had 6 levels of transitive dependencies, including one near the bottom, which was a red, and I'm like, I never would have looked that far when I was a developer. Anyway, don't look at me, I'm maybe a bad example. Number 2, shift left. So empower developers by giving them information into their IDEs and source control. Because wouldn't it be great if we could know what we're using, if it's safe, if it's not, and then pass it on? Like I said, there are so many more developers than security. Why don't we make security's life easier by, not passing defects downstream? Oh yeah, and then point 3, add checks at every stage, like I just said, to ensure you don't pass defects downstream. Because, as I said, maybe you built on March the 6th, then there was the struts vulnerability, deploy on March the 8th. So you need to make sure that you're constantly checking, because there's new vulnerabilities coming out every day, because the application layer is where all the hot hacks are. So why don't you have something in the IDE, have something in CI, repository, deployment, etc. So that is the end of my talk. If you want to find out more or ask me any questions, we do have, Sonatype has a booth. It's kind of against the back windows. And then we also have, for all of you lovely attendees, I've got 2 of my colleagues at the back, we have free Yeti mugs and Legos. So we've got little things to hand out. So if you come to the Sonatype stand, I can give you a little custom Lego figurine as well. Cool, thank you.